In the last video, we went over examples 1A through C, and we used this property here. That's always the first property you want to look for. If you can get a log base on both sides that are equal, then you can cancel them out, and then it just becomes a simple equation. While this is the first thing you want to look for because it's the easiest way to solve, most of them you can't solve by that method. And so now we're going to follow these two steps here. The first thing you want to do is isolate your logs. You want to get your log by itself on one side of the equation. Usually that's going to consist of condensing by either when you see a plus in between, we're going to multiply, or when you see a minus in between, you're going to divide. So we need to isolate the log. And then you are going to take the appropriate exponential on both sides. So now we're going to be using this inverse property right here. And it says also avoid extraneous solutions. Goodness. Also avoid extraneous solutions by checking your solution, which we did in this example here. And we will continue doing as we work through these. So this is the inverse property I want to use. So just like adding and subtracting are inverses of each other. Multiplying and dividing are inverses of each other. Square roots and squaring are inverses of each other. Cubic root and cubing are inverses of each other. Having a log with a base of b, if I take that same base and I now raise it exponentially with that same base, because these are the same, they cancel out and you are left with whatever you have over here. So for example, on D, I have isolated my log because you only have one log over here on the side. So here we have log base 2. Because this is a base of 2, I want to now take this as an exponential, and my base of this exponent is a base of 2. So you have 2 log base 2, just like here, we have b log base b. Those cancel and you're left with whatever's over here. So when these two cancel with each other, now I am simply left with 5x. Now we are not done, because just like adding and subtracting, multiplying, dividing, squaring, square rooting, whatever you do to one side of the equation, you also have to do to the other side. So we are taking the appropriate exponential on both sides. So if I am raising this one as an exponent with a base of 2, then this one's also going to have a base of 2. And so 2 to the 4th power, 2 times 2 is 4, times 2 is 8, times 2 is 16. Now I can solve. Now I've gotten rid of my log and I've also gotten rid of my exponent in this case. And so now it's just a linear equation. So we'll divide both sides by 5. And x equals 16 over 5. And you always have to check your log equations to make sure that you don't get a negative anywhere. So when you plug in 16 over 5, 5 times 16 over 5 is 16. So we do get a positive right there. So that is my answer. Okay, let's try again. Here we have log of x plus 6 equals 1. So there is a known base here of what? Of 10. So your common log. So because I have a base of 10, I'm going to raise this as an exponent with my base of 10. And what I do to one side, I'll do to the other. So I will raise this side as an exponent with its base of 10. So 10 to the log base 10 power, those cancel, and I am just left with x plus 6 equals, and then you have 10 to the 1st power, which is 10. I'll subtract my 6, and we get x equals 4. When you plug it in, do you get a positive log? 4 plus 6 is 10, and so that does work. Okay. On F, Your log is isolated, so we have log base 3. What undoes a log base of 3 is raising that whole side as an exponent with a base of 3. So I will do that also to the other side. So 3 to the power of log base 3, those undo each other, and you are just left with 1 minus 2x. And then 3 cubed, 3 times 3 is 9, times 3 is 27. So solve. We'll subtract our 1. We get negative 2x equals 26. Divide by negative 2. And we get x equals negative 13. When I plug that in, do I get a positive log? Negative 13 times a negative 2 is positive 26. So you've got 1 plus 26, that is 27. That's okay. So it's okay that your x is negative. It's when you plug it in, do you get a positive? Okay, so let's get a little bit more complicated now. So far, all of these have had their log already isolated. Let's see what happens here when all of a sudden they are not isolated anymore, like on your next problem, G. So on G here, I need to get this log isolated. To do that, because this is a plus right here, and they both have the same log base, right? These are common logs with a known base of 10. I can condense them by multiplying. So this becomes log of 5 times x plus 2. This still equals 2. I'm going to distribute that 5 here. So we have log of 5x plus 10 equals 2. So now I have a log isolated, and it is now simplified, right? So now how do I get rid of a log? Well, because it is a common log with a known base of 10, to undo a log of a base 10, I'm going to raise this as an exponent with a base of 10. And what I do to one side, I have to do to the other. So 10 to the power of log base 10 cancels out, and you are only left with 5x plus 10. And then 10 squared is 10 times 10, so that's 100. So now just solve. We'll subtract our 10. That's what would help if you could see. And divide by 5. And I went ahead and boxed it, but I shouldn't have yet because I did need to check it. There's nothing to check with this one because it doesn't have an exponent. Log of 5 is a number. But when you plug it in here, you've got 18 plus 2, so you get log of 20, and so that's positive. That's okay. On H, it's kind of the same thing. Here, you have a plus. So I know that plus means that I can condense it by multiplying m and n together, and my m is x, my n is x minus 21. So to isolate the log, we will condense this to log of x times x minus 21. I'm going to distribute that x, so we get log of x squared minus 21x, and that equals 2. This is another common log. So to get rid of a common log with a base of 10, we are going to raise each side as an exponent with the base of 10. I can raise this to any power that I want. I am purposely picking the same base as that log, so they will cancel. And now I'm left with x squared minus 21x equals 10 squared is again 100. So here, this is the first time that we have not had a linear equation. We now have an exponential, or sorry, a quadratic, right? You've got a squared. So we can solve squared or quadratic equations by the square root property, factoring, or quadratic formula. I can't use the square root property because I do have a b term. So let's move this 100 over and see if we can factor first. So I'm going to move that over by subtracting it. And now let's try factoring. I have no GCF, so I will go into my x. My a times c is 1 times negative 100. And my b term is negative 21. What adds up to negative 21, but multiplies to a negative 100. And that is negative 25 and a positive 4. Negative 25 times 4 is negative 100, but negative 25 plus 4 is a negative 21. This is an easy trinomial. So it will just factor to x minus 25 times x plus 4. When I set this equal to 0, we get x equals 25. And when I set this equal to 0, we get x equals negative 4. Plug them in before you say that those are the answers. 25, when you plug into this x, that's log of 25. That's a number, that's fine. When you plug in 25 here, you get 25 minus 21, which is 4. So we get log of 4. That's great as well. Here, right from the get-go, when you plug in negative 4 here, that doesn't work, and it won't work here as well. So this one is not an answer. This is my only answer here. Okay, one more problem like that one. Here we have a plus. This plus tells me that I can condense this by multiplying my n and my m together. So this is log base 5 of x plus 2 times x plus 6, and that still equals 1. So FOIL this out, and we will get log base 5 of x squared, x times x, then you got x times 6 and 2 times x to get plus 8x, and then 2 times 6 to get 12. Okay. What am I going to raise this log base 5 of? This needs to be raised to the exponent with a base of 5 because it's a base of 5 here. And what I do to one side, I will also do to the other. So those cancel. 5 raised to the log base 5 power cancel each other out. And we are left with x squared plus 8x plus 12. 5 to the first is just 5. So we have another quadratic here. I can't use square root property again because I do have a b term, so I need to move this 5 over. We'll move it over by subtracting. So 12 minus 5 is 7. So let's factor. My a times c is 1 times 7. My b term is this 8. What adds up to 8 but multiplies to 7? And that is 7 and 1. This is an easy trinomial. So this is x plus 7, x plus 1. When I set this equal to 0, I get x equals negative 7. When I set this equal to 0, I get x equals negative 1. Do either of these work? Well, when I plug in a negative 7 plus 2 is negative 5. That does not work. It doesn't work with this one either. -7 plus 6 is -1. When I plug in a -1, does that work? Well, -1 plus 2 is a +1, so that's okay here. What about here? -1 plus 6 is also a +5, so this is my only answer. Okay, last three problems with logs. And with these, we now don't have pluses, we now have minuses. So to condense a minus, that means I'm taking my m and my n and I am dividing. And order will matter here, so we always need to do the first divided by the second. So here we've got log, or natural log x equals the natural log of x plus 6 divided by x minus 4. This one actually goes back to our first video. My bases are going to cancel and I'm going to be left with m over n, or m equals n. So here on both sides, we have the natural log, so we can cancel those out. And I am left with x equals x plus 6 over x minus 4. Now you can solve this by getting rid of this in the denominator, but I think the easiest way is to almost treat this as a proportion. So instead of this being x, I will make this x over 1, and then I'm going to cross multiply. So when I cross multiply this way, we have x times x, which is x squared, and x times a -4, which is -4x, equals, now cross multiply this way. 1 times x is x, and 1 times 6 is 6. So we have a quadratic again because you have an x squared. So let's get everything to the same side. So subtract your x to get -5x and subtract your 6 to get a -6. Let's factor. A times c is -6 and my b is -5. What adds up to -5 but multiplies to a -6? And that is -6 and 1. -6 times 1 is -6, but -6 plus 1 is a -5. This is an easy trinomial. So this is x minus 6, x plus 1. When I set this equal to 0, we get x equals 6. And when I set this equal to 0, we get x equals -1. So plug them in and see if they work. When you plug in 6, you get the natural log of 6, that's good. Here you get the natural log of 12, that's good. And here you get the natural log of 2. So this is an answer. Now try -1. And right from the get-go, it does not work. It does work here, right? -1 plus 6 is 5. And it does not work here either. So it does work on 1, but that doesn't matter because it doesn't work on these other 2. So it's got to work for all of them to be a solution. Now, this is going to be the same problem as this, but it does look different. Here, this is the first time that we've had multiple logs on different sides of the equation. I guess we did have it here, but I was able to condense and eliminate my logs. But up until now, we've had logs always on the same side of my equation. I need to end up doing that here. And so to do that, I'm going to subtract this log to the other side. So it cancels over here. And now over here, I have log of 4x plus 3 minus log of x plus 2, and that's still going to equal 1. So now this problem is set up more like this one. Now I have a log or two logs on the same side of the equation. And because this is being subtracted, I am going to condense it with division. Okay. So this will become log of 4x plus 3 over x plus 2 equals 1. Now before, when I did my division, you had the log on the same side, and so they canceled. I don't have that here. So now we have to do what we've been doing. How do you cancel out a log with a base of 10, right? That's a common log. If you don't see a base, there's a known 10 there. To do that, we'll take each side as a exponential with a base of 10. So now 10 to the log of base 10 power, that cancels, and I am left with 4x plus 3 over x plus 2. And then 10 to the first is 10. I think it's easiest to just treat this as a proportion. So I will rewrite 10 as 10 over 1 and cross multiply. It doesn't matter which way you cross multiply first. Here I went upper left to lower right. This time I will go this way. It does not matter which way you go. So remember to distribute this. So this is 10 times x and 10 times 2 equals 1 times 4x and 1 times 3. Now we have a linear equation again. All right. So we'll subtract 4x over. We get 6x plus 20. And I'm actually running out of room, so let's go ahead and do that. Let's just subtract our 20 over as well. Cancel, cancel. So 6x equals negative 17. Divide by 6, and we will get x equals negative 17 over 6. Okay, so plug that in and see if it works. Now, a lot of times we get really stumped on these fractions. Don't let it stump you. Just plug it in. You can use your calculator if you need to. When you plug that in, we've got 4 times negative 17 over 6 plus 3. And that's going to give me a negative. So I'm going to have log of a negative number here. That does not work. So because this is my only possible solution, and my only possible solution doesn't work, that means this equation here has no solution. Okay, let's try one more problem like this. This is kind of as complicated as your log equations are going to get. Okay, and L is going to be the exact same. Okay. So you have a log on both the left and to the right, so I need to subtract this log over. So we will do minus log base 3 of x to both sides. Cancels over here. You can't combine these, so just write them side by side. You got log base 3 of 2x minus 5 minus log base 3 of x, and the only thing you have left over here is this 3. Okay, so these are both log base 3s. Because this is a minus between them, we're going to divide m by n. So we have log base 3 of 2x plus 5 over x equals 3. So now to solve this, I need to get this log, I need to get rid of it. So how do you undo a log with a base of 3 Well, you raise both sides as an exponent with that same base. So now 3 to the power of log base 3 cancels. And we are left with 2x plus 5 over x. And 3 cubed is 27. Treat this as a proportion. So we will make this 27 over 1. And now cross multiply. X times 27 is 27x equals 1 times 2x is 2x. And 1 times 5 is 5. So now it's a linear equation. Let's solve for x. So we'll subtract our 2x over. And we get 25x equals 5. Divide by 25. And x is going to equal 1/5. So does that work when we plug it in? Well, you have 2 times 1/5, that's positive, plus more is positive. And then this would just be log base 3 of 1/5. So this one does work. Okay. In the next video, we'll start going over how to solve exponential equations.